This lesson is function operations. So anytime we talk about operations, and you can see it in the learning target, we're talking about I can add, subtract, multiply, and then there's going to be one new one, compose functions. We're not going to do dividing functions because that's going to be in a later unit and you're going to be sick of it. So I'm going to skip it for right now, and we're just going to look at adding, subtracting, multiplying, and then a new thing called composing. Okay. So this notation may be a little different for you. So there is an f of x function, and that is 3x minus 2. And then you have another function, g of x, and that's x squared minus 2x plus 4. And if you look at the problem, it says find f plus g evaluated at x. So literally what it's telling you to do is take the f of x function and add it to the g of x function, which is what we're going to do. Okay, so f of x was 3x minus 2, and we're going to add that to the g of x function, x squared minus 2x plus 4. So if you remember from previous math courses, all you got to do is start adding like terms. So the biggest exponent I see is x squared. I'm going to do this in orange. There's no other x squared to be added, so you're just going to have 1x squared. Now I'm going to put a slash through it just to make sure I understand that I've used that one already. Okay, then from x squared, the next one I see are x's. So we have 3x minus 2x, which combines to just be minus x. If that freaks you out, you could put a 1 in front of that x. It's just not really necessary, but it's not wrong if you want to do that. And then the last thing, we have a minus 2 plus 4. Minus 2 plus 4 is plus 2. And so that is my answer. It's in standard form because the biggest exponent is first, and then it goes down, and I've combined all like terms. So that is how you add functions. Pretty easy. Alright, so we're going to use the same two functions we just used, f of x and g of x. And now this one says we're going to do f minus g evaluated for x, which literally means the f function subtract the g function. Now this one kind of gives people a little hard time, so let me show you what I'm talking about. So f 3x minus 2, and we are subtracting the entire g function. So the g function is the one in green, x squared minus 2x plus 4. So we are subtracting that entire function in green, which means we have to distribute, think of this being a negative 1, to everything in the parentheses. Okay, because you are subtracting that entire quantity, you have to distribute that negative 1 to everything in the g function. So I'm going to show you what I'm doing. Okay, so the f function stayed the same, and now the g function is going to become a negative 1 distributed to a positive x squared is negative x squared. A negative 1 distributed to a negative 2x is a positive 2x. And a negative 1 distributed to a positive 4 is a negative 4. So now you've taken care of that subtraction sign. You've distributed to everything. Now all you have to do is your like terms. So the biggest exponent I see is that negative x squared. There's nothing to combine it with. I'm going to cross it out to let me know that I'm done with that one. The next thing I see are the 3x plus 2x. 3x plus 2x is 5x. I'm going to cross them out. And then the last thing I see is negative 2 minus 4. That's a negative 6. So that would be my final answer. So when you're subtracting functions, just make sure that you subtract the second function. You distribute the negative sign to everything in that second function. Alright, now let's do multiplication. And then remember that multiplication is also denoted by just a little dot, so that's the same thing. So if you saw either one of those, same thing. And this is literally telling you you're going to do the f of x function times the g of x function. So here's my f, here's my g. Now because we are multiplying two quantities, that is when you use parentheses. So anytime you multiply two different quantities, you have to use the distribution method. I don't know why I said that so weird. I was trying to write and say something at the same time, and it just sounded awful. Okay, whatever. I'm blabbering. So I'm going to color code this one. We're going to take 3x, and we're going to multiply it to everything in the next function. So 3x times x squared is a 3x cubed. 3x times negative 2x is negative 6x squared. 3x times a positive 4 is a positive 12x. So we have distributed that 3x to everything in the second function. We have not done the negative 2 yet. So I'm going to distribute negative 2 to everything in the second function. So a negative 2 times an x squared is a negative 2x squared. A negative 2 times a negative 2x is a positive 4x. And a negative 2 times a positive 4 is a negative x. So now we're just going to get our like terms together. I see this is the only x cubed. So it's just going to go down here and I'm going to cross it out. Next I see that I have negative 6x squared and negative 2x squared, which becomes negative 8x squared. Next I see 12x and 4x, which is 16x. And then the little 8 by itself. So that's going to end up being my final answer. Notice it's in standard form because the biggest exponent is first and then it goes down. Okay, so this should not be new information, but maybe you've just never seen the notation quite like that. So this is just reviewing, getting it back in your head. Okay, so what I want you to do is I want you to pause the video and I want you to try these 3 examples. You're going to add the functions, you're going to subtract, and you're going to multiply. So pause the video in 1, 2, 3. Okay, so if you got a little stumped, you can push the play button or you can just check your answers. So I'm going to add the 2 functions together. F of x is x squared plus 4. G of x is plus 3x minus 1. All I have to do is get my like terms together. This one's pretty nice. There's only 1x squared, check. There's only 3x squared, check. And then 4 minus 1 is positive 3. So there's my answer. And I'm going to erase this really quick. Alright, so for the next one, I'm going to do f of x minus g of x. So f of x is x squared plus 4. And then remember that we are subtracting the entire quantity, 3x minus 1. So this is when you distribute the negative sign. So you can think of it as being like a negative 1. So I'm going to go ahead and distribute everything. A negative 1 times a 3x is a negative 3x. A negative 1 times a negative 1 is a positive 1. So now I'm going to get my like terms together. There's only 1x squared to put together. There's only 1 minus 3x to put together, and then I have 4 plus 1, which is 5. Alright, so hopefully you got that right. I'm going to erase it. So in this example, we're going to do f of x multiply g of x. And I'm going to put these in parentheses because that's the entire quantity being multiplied to the next quantity. I'm going to use some different colors just to denote some stuff. So we're going to distribute the x squared to everything in the second parentheses. X squared times 3x is 3x cubed. X squared times negative 1 is negative x squared. I need to distribute the 4. So 4 times 3x is plus 12x. 4 times negative 1 is negative 4. And what's really nice about this one are there's no like terms to get together, so we are done. And we just used the FOIL method, so if you loved using the FOIL method, oh my gosh, I hate it. I just want to jab my eye out when anybody says it. That's what you're using. Blah, blah, blah. All right, moving on. Okay. So this is a new operation. So when we see a plus sign in math, we know it means to add. When we see a negative, we know that means to subtract. And if we ever see this dot right here, we know that means to multiply. So anytime we see a closed circle, that means what we're going to multiply. So what we're going to do is look at a new operation. You've probably never heard of it, unless, I don't know, you really like math and you just watch random YouTube videos of it. That could happen. This is called a composition of functions, and that's this open circle that you see between the O and the G. So that is actually not the word fog. It usually looks like this. It's like a tiny little G, and you pronounce that F of G. And that is called a composition of functions. And what that means is we're going to put one function inside the other. So it's a little weird at first, and we'll do some examples. Okay, so composition of functions. F of G of X. What it means is I'm going to take the first function, and it's going to be my outer function. I'm going to take the second function, and it's going to be my inside function. So if you see in that little picture, the G of X is inside the F function. That's what you would do. You're always going to start with the innermost function parentheses or the function at the right. So you have to pay attention to the order of the letters, because F of G is not going to equal G of F. Okay, I know that's really confusing. We'll do some examples. So here are two functions. I have f of x equals x squared, g of x equals 2x plus 3, and I'm going to find f of g of 3. That's how you pronounce this. I know it's a mouthful. F of g of 3. Okay, so what this means is, since f is first, it's going to be my outermost function. It's my one in green. And g is second. It's going to be my inner function. And then whatever is right here is what I'm evaluating it at. So I'm going to evaluate it at 3. Okay. So I'm going to do the middle part. I'm going to do this. Let me do the same colors. I'm going to evaluate the g of x function, this one right here, for 3. I'm going to replace that purple x with a 3. So I had a 2. I'm going to replace it with 3. And I'm going to do everything else the same. So all we did was we took this function and we replaced the x with the value inside the parentheses. And now we're going to simplify it. 2 times 3 is 6. 6 plus 3 is 9. So g of 3, when I evaluate the g function for 3, I get 9. Okay. Okay, so now I'm going to take the value I got for g of 3, which was 9, and I'm going to evaluate the outer function, the f function for 9. So I'm going to take this 9 and replace the x with 9. So it's going to look like this. 9 squared. Because that's exactly what this says. Something squared. We know that x is now 9, so it's going to be 9 squared. And 9 squared is 81. That's my final answer. A composition of functions is taking one function and putting it inside the other. So look back at this. We took 3 and we plugged it into g, and then we took that answer and we plugged it into f. When we plugged 3 in for g, we got 9. When we plugged 9 in for f, we got 81. 81 is going to be our final answer. Okay, so now we're going to use the same two functions we just did, but we're going to find g of f of 3. So g is our first one. It's going to be our outer function. F is going to be our inner function, and we're still going to evaluate it for 3. So the first thing I need to work on is finding what f of 3 is. I need to find f of 3. So I'm going to take 3 and I'm going to plug it in where I see x in the f equation. So it's going to be 3 squared. 3 squared is 9. Okay, so when I evaluated f of 3, I got 9. Alright, so now I've done this part. And now I need to figure out what g of 9 is. When I replace x with 9, what do I get? So 2 parentheses 9 plus 3. 2 times 9 is 18. 18 plus 3 is 21. And that's my final answer. I took 3, I plugged it into the f, I got 9. I took 9, I plugged into the g, I got 21. Okay, so now what we're going to do is we're going to look at evaluating the function just for an x. So it works the same way. F is still going to be our outer function because it's the first one. G is going to be our inner function because it's the last one. And we're going to evaluate it for x. So, see in the middle, I just have g of x. G of x is already evaluated for x. It's 2x plus 3. So literally what we're going to do is we're going to take 2x plus 3 and we're going to plug it into the f equation. Okay, so the f equation is up here. I'm going to replace that x with 2x plus 3. So I have 2x plus 3. And it says whatever you plug in for x, you got to square it. So that's what we're going to do. Okay, so if you remember back from previous math courses, anytime there is a quantity squared, what that means is you write the parentheses twice. And if you forget that step, you're going to get the wrong answer. Alright, so anytime you have a parentheses squared, write the parentheses twice. And now we're going to distribute. Let me use some colors. Alright, I'm going to distribute that 2x to 2x and get 4x squared. I'm going to distribute 2x to 3 and I get 6x. Use another color. Now I need to distribute the 3. So 3 times 2x is 6x. 3 times 3 is 9. And now I'm just going to add some like terms together. So there's nothing to add to the 4x squared. We're good. And then I have 6x plus 6x, which is 12x. And then the last is I have plus 9. I know that's a lot. So I took the x and I evaluated it for g, which is my purple equation. I took my purple equation and I plugged it into my green equation. And then I just did the math. Let's look at another example. We're going to use the same functions, but this time g is going to be our outer function and f is going to be our inner function. Okay, so f of x right here, I'm going to evaluate it for x, but it already is evaluated for x. So really all I'm going to do is I'm going to take that x squared and I'm going to plug it into the g equation. So I'm going to take this x squared and I'm going to plug it in to where I see x. So I have a 2, I'm plugging in the x squared, and I have plus 3. So 2 times x squared is 2x squared, plus 3. There's no like terms. That's my final answer. Okay, let's do one more. Alright, this one looks a little funky, and I'm definitely going to put one like these on the test. Wink, wink, nudge, nudge. There was me being helpful. So f is my outer function, but in this case, f is also my inner function. A little weird, but sometimes this is what happens. You'll see this more in pre-cal. So I'm going to take f of x, which is x squared, and I'm going to plug it in to, okay, let me do this. So here's x squared, And that is the value of f of x. So I'm going to plug it in there again. So it's like I put x squared inside of x squared. And if you have x squared to the second power, if you'll remember back from Math 1, anytime you have a power to a power, that's when you multiply. So your answer ends up being x to the 4th. Alright, I'm going to put some more practice problems on haiku. You can always contact me. I know that one's a little hard. I'll try to find another YouTube video with maybe another teacher explaining it in a different way, and maybe it'll help also. Alright, so contact me if you have trouble, and that's it. Bye.